Hi there, ladies and gentlemen. Today we're going to be looking at slope. I'm hoping this is a little bit of a review for you guys. If not, then obviously be sure you are paying extra close attention. Remember, slope has to do with a straight line and a straight line only. Those straight lines can be diagonal. Those straight lines can also be vertical and horizontal. So when we talk about a rate of change, we can also be talking about a unit rate. So rate of change can also be a unit rate. It's going to be one of those. So for some examples of a unit rate or using our domain and range, it's going to be, this symbol right here means change. So it can be change in your dependent variable over change in the independent. Or we can say change in y over change in x. But when we talk about unit rate, some of those unit rates can be price per pound. We can talk about miles per hour. This one's pretty common. And maybe stuff like cost per item is another big one. So these are some of the more common unit rates or rates of change. So I already brought up the ratio. Remember, when we have a ratio, this can be m equals. So it's our slope. M is our slope. And we're talking about that change in the dependent over the change in the independent. The way we would read this is change, if I could spell, in y over change in x. So we're looking at a ratio or a fraction with the change in y over the change in x. Remember, this ratio can always simplify, or not always, but sometimes simplify to a whole number or even a decimal, you may see, if it has to do with money potentially. Another ratio is like when we have a graph, we can also talk about rise over run. So this would be vertical change, so up and down, over horizontal, left and right. So again, vertical over horizontal. Now the first way we are going to find our slope is using a table. This one is the most consistent. Remember, we're always going to do change in y over change in x. So when I look here, I'm going to look at my, sorry about that, I'm going to look at my change in y. If I'm going from -2 to a -1, this is a +1. Same thing here, +1, and here, +1. So that means our change in y is a +1. Now I'm going to look at our change in x. We're going from a -4 to a -2. That means we're adding 2 each time. It's becoming more positive or larger, so that'll be a +2 each time. So then I'm going to put +2 here. Now I put the plus and minus there so I don't lose track of whether or not it's positive or negative. Of course, I can't simplify 1 over 2, so then our slope in this case is 1/2. If it were money, it would be like $0.50 for something. Let's try the next one. Again, this is a horizontal table, but we still treat it the same way. We're still going to do change in y over change in x. So my change in y each time, I guess I wrote that a little too close to my table. Let me move that down. So we're going to do change in y over change in x. So my change in y each time, it's getting more negative this time, so we're subtracting 3 each time. So our change in y is a -3. While our change in x is getting bigger each time. So this would be a +4 each time. So when I have a positive and negative, that makes the whole thing negative. So In this case, our slope is a negative 3/4. Remember, y is always on top. And this is what sometimes you'll hear it referred to as a rate of change, which we talked about a little bit already, or unit rate. All right, so let's look at finding slope between 2 points. Let's say I give you the ordered pair 0, 4, and 6, 12. If I could write it. There's our ordered pair. Now, some of us are, have a hard time keeping track. The equation is actually y2 minus y1 over x2 minus x1. But for me, that can be a little bit tricky. So what I'm going to do is stack my ordered pairs. So I'm going to stack them. I'm going to do 0, 4 and 6, 12. So I'm just lining them up. And I'm going to use it as if it's like a little table. So I'm going to subtract my y's, because remember, this is x, this is y. So my change here is 4 to 12. So that means I'm adding 8. So my change in y is a plus 8. While my change in x is a plus 6. So 8 over 6. But of course, I can simplify. Both of these are divisible by 2. So when I simplify, I end up with 4 over 3. Leave it improper. There's no sense in changing it to a mixed number. But be sure you're always simplifying. That's a big piece, because if it's not simplified, then it's not accurate. All right, let's look at our next set of ordered pairs. Let me kind of separate that there. All right, our next set of ordered pairs, I have we'll go negative 2, 7, and 2, negative 1. Again, I'm going to stack them. So when I stack them, I'm going to have negative 2, 7, and then 2, negative 1 on top of each other. I'm still going to find my change in y over change in x. So let's see what we have here for our change in y. We're going from a positive 7 to a negative 1. So in this case, it's going to be minus 8. On the other side, we're going from a negative 2 to a positive 2. So that's going to be a plus 4. Now, I don't know if you noticed this, but 8 is divisible by 4. So this is going to simplify to a nice pretty whole number, except one is positive, one is negative. So this is going to be a negative 2.